All right, so here's a look at page 2 on the review. So a couple things. We've talked a little bit about this type of in class. A parallel line is something as a descriptor of slope. So to say that I have a graph that's parallel to something really is saying, hey, it's got the slope the same as, and in this case, a line y equals 2x minus 3. And that line, you can just steal the slope right out of course, it's 2, the number multiplied to the x. So what we're going to do is, when is my function f of x does it have the same slope as that line? In other words, when is its derivative, the slope generating tool for f, is it equal to 2? So we're going to set those guys equal. The derivative, got it, set it equal to 2. We're going to solve the x that we find is the x value at which my function f has a slope that's equal to 2, which in turn means it's parallel to this line y equals 2x minus 3. So it's just borrowing some knowledge that, when I say parallel, that means same slope. And if I'm going to compare it to the slope of my function f of x, I need to get the derivative of f of x, set it equal to 2, and solve. And there it is, x equals negative 3/2. The next problem is find the second derivative, which means derive twice. There's some pretty crazy simplifying going on in here that could take place, but I don't do a whole lot of it. What I have on here, very densely packed into the page, is me taking the first derivative, simplifying a little, taking the second derivative, simplifying very little, if any at all, but I'm going to put 1 in for x and then just evaluate it from there, because this does say find f double prime and sub in 1, so what we're looking for, hey, what's the concavity at x equals 1? And here's the work that goes with it. So here's your first derivative. I see quotient rule, and there's other ways to go at it, but that's what I see. I see two things being divided, and it's an easy way to start. I don't have to think hard about it. My low d high less high d low, over the square of low we go. It's a pretty quick jump. Something to note is that the square root of x could be written as x to the 1/2 at any given time, if that helps. And it does when I'm taking the derivative of the denominator. It's helpful to have it as x to the 1/2 plus 1. And you'll see that in here I derive the bottom and the second half of the numerator after the minus. So minus 1, and then that's that high d low. And you can see the derivative of x to the half is 1/2 x to the negative 1/2. And the derivative of the plus 1, of course, is 0. So there you see the complete first derivative. A little cleaning up, especially since the first part has a 0 in it, takes you to this expression. I could go further with my simplifying, but if I'm going to take the derivative again, this is not too bad. It's a quotient rule again, so I just went ahead and went with it. So here I am doing the quotient rule again. I set it up, low d high, and then minus high d low, and I put a minus. I wrote this, and then I realized my ninja writing that I'm writing so fast inside here. Don't mind, I saw that I put a plus in there instead of a minus, so watch, I'm going to take that out right now. Got that. I'm going to put my minus in there. So there, minus high d low. Thanks for hanging with me. And then keep on rolling. The derivative of the low is a little bit tricky, so I've set it off to the side here so you can see it. It's a chain rule as I've written it. Again, you could try and distribute that out, but I'm going to just do it as a chain rule. The derivative of the outside is this something squared, so I put 2 out front, the inside untouched to the first, times the derivative of the inside, the x to the half plus 1, and I place that at the end. You multiply by the inside at the end, the derivative of the inside. So it's a nice little chain rule. Then that's how I got, if you kind of follow ever so carefully, I'll put a kind of a light orange line that traces it out for you. It goes right here. You can see the work of that derivative is placed in the second half. Remember, it's low d high less high d low, and that's my d low. And then at the bottom, over the square of low we go. Voila. And then all you have to do now is put 1 in there and do your subtraction that goes with it. And if you put 1 in there and keep rolling, we're going to have, I think that minus sign didn't creep in there again. We'll just kind of fix it as we go along. It happens. So here, I might get that minus supposed to be in the middle. I'll put a minus in orange because it'll stand out. Okay, can you see the pieces that are going on right now? All this is me putting 1 in for x in the numerator. And if you carefully put 1 in for each x in the numerator, then you get 2 for the first parenthesis, 4th for the second one, negative 1/2, 2. So it's just putting in 1 for the x's and not doing any of the exponent work. I'm just kind of leaving that for later. And then I'll keep going. And if you keep going, if you drag that out and actually subtract this correctly, you do get 1/8. And that's with the minus corrected and all that. I just miswrote it inside there. So if you type that into a calculator and calculate it out, you get 1/8. The biggest piece of it is can you do the derivatives? And I don't get lost in, there's some arithmetic that needs to take place in there, some exponents. You'd have a calculator to make this calculation. 2 times 2 to the second times 1/4 to the negative 3/2. All that can be done in your calculator. Just carefully type in and add, subtract, and multiply as necessary, and you'll get the 1/8 you need. Okay, so there's one more problem on this page 2. It is the second, number 4 here. It says determine the equation of the tangent line. So when that pops up, determine the equation of the tangent line, you need to immediately write this expression. This is the equation of a line, and it needs a slope and a point with an x and a y coordinate. The slope, of course, will get, because it's tangent to the curve that's drawn, this parabola you see to the left is 3x squared minus 2x plus 1. If I want to know its slope at any given time, I need to get the derivative, so I will. And to get a point, 1, 2, I've got, sometimes you only have x and you have to sub x in to get y, but in this case you have both, 1 and 2, which goes in for x1 and y1. So that's pretty nice, but the derivative I need to get, so and put 1x equals 1 into it, because the derivative will have an x that you can sub the x value of our point into. Okay, so I'll take the derivative. In a moment, I subbed in the 1 and the 2, the point that was given. Now let's get to work on my y prime, and then let's put 1 into it. So there's y prime, pretty nice. Sub 1 in, get 4 out, plug that back into your equation. That's it. You're done. The equation of the line doesn't need to be simplified. Don't need to write it, set it equal to y, or if it's just an equation, this is called point-slope form, and it's the nicest one, a great place to sub your slope and one of your points, and you're on to the next piece. So that'll end page 1, and it does say draw the tangent line on there, do a little sketchy sketch, and that's it. Just make sure you understand how to draw a tangent line, and I can see that you know how to draw a tangent line at a given point. Next video will come up shortly.